What is the most effective way to prepare for the PE Power exam? Should you study broadly or deeply? Is it important to solve every single question quickly? Will you be in a race against time on the exam? How helpful is the NCEES PE Power Reference Handbook when you are preparing for the PE Power exam? Are there certain sections within the PE Power exam that are more important than others? If you don't have any background in codes and standards, can you still prepare for and pass the PE Power exam? In this video, I'll be answering these questions in detail. It's an extract from a live training session that I conducted with my students who are preparing for the PE Power exam, which is one of the final steps before getting your PE license. So without further ado, let's dive right into it. Now, PE Power does not have 17 sections. It only has 4 sections. And if you want to consider each subsection as a line item, then basically we are looking at 9 line items, 9 subsections. As I mentioned earlier during the PE Power versus FE Electrical comparison, FE Electrical is really a test of fundamentals, but there are lots and lots and lots of fundamentals to cover, ranging from math to software and everything in between. PE Power, obviously, you cannot have in-depth understanding without knowing the fundamentals, and that's where you have to be really focused. That if they include a line item and say instrument transformers, don't think that I am going to pick up the reference handbook, which will be provided to me on the exam, and plug and check my way through all the questions related to instrument transformers, because you will be in for an unpleasant surprise. Why? Pull up the PE Power Reference Handbook, try and find instrument transformer. You won't find it there. Okay? So our reliance on the reference handbook should be very, very limited in the PE Power exam. And that makes a lot of students uncomfortable. They're like, but the reference handbook should contain all the formulas, all the theory that I'm going to be tested on. Not at all. Look at the specification. The specification gives you an outline, and the reference handbook just gives you a general lay of the land. All right. In my PE Power program, and students start working through the measurement instrumentation subsection, they encounter 5-part lecture series on instrument transformers, 5 sets of quizzes. I have folks who have 10, 15, 20 plus years of field experience. They've been doing protection and control. They go through my content on instrument transformers and they're like, Wasim, actually, this was so refreshing because I didn't properly understand what was the right way of looking at the knee point, okay, the saturation curve, the excitation curve. How do you really calculate burden for an instrument transformer, for a CT, and so on? So section number 1, right up front, you're going to encounter a topic which is not given in the reference handbook. And this should be a wake-up call, okay, that you cannot rely on the reference handbook. 4 to 6 questions, that's about 5 to 7% of the exam. General power engineering is by far the heaviest topic, along with section number 4, and it has 3 subsections. So this is probably the most disjointed section of PE Power. They're throwing instrument transformers at you, installation testing at you, ground resistance testing at you. Then they have a subcategory applications. They're throwing lightning protection at you, surge protection, reliability. So there's not a very clear through line, right? And that's why it's called general power engineering. If you work in the field, then you probably have some exposure to each and every one of these topics. Grounding. I actually have a 4-part lecture series on grounding, and part number 4, if I'm not mistaken, is 60 minutes long. Okay. And it discusses the different configurations that you would encounter in real life when you're dealing with grounding design. Ungrounded system. Why do we have the first fault happening on any one of the phases? So if you have ungrounded system and the first fault that happens, one of the phases goes to ground, what happens? If I have overcurrent protective devices on each one of these lines, and if I have a SLG, single line to ground fault happening, what will happen, guys? Will any one of these devices operate? There's a fault condition, right? Let's say phase A went to ground. Do you think any of the phases, any of the OCPDs will activate? It's a simple answer, right? It's either a yes or a no. Correct? Okay. What do you guys think? Is it going to be a yes or a no? Okay, you guys are being shy. The answer is no. But that's level one understanding. Why no? Why does the first line to ground fault on ungrounded system results in does not result in activation of the OCPD? So you're saying no neutral. Sure. What does neutral have to do with it? You're along the right train of thought. But what does neutral have to do with it? And how would you explain it in terms of sequence components? The reason is that when we have one of the phases grounded, there is no return path. Okay? If the current wants to go here, it cannot go back to the source because there is no return path. It's not a complete loop. And a delta system by itself presents infinite impedance in terms of zero sequence. Are you guys following me? But now if I have another phase that is faulted and it becomes a DLG, double line to ground fault, now this becomes a complete path. See this? Because this ground is going to be connected to this ground, and now we can have the current flowing between the two phases, and now the OCPDs are going to activate. So within the last 60 seconds, I basically tested or presented you guys with a fine concept that is buried deep in grounding. And the way that I asked this question was still very straightforward, and I was sort of leading you to an answer. Imagine an examiner testing you, teasing you on this concept by keeping the key, the crux of the solution kind of hidden and expecting you to sort of make all those connections on the exam. Okay, that's what the P power exam is. All right. And interestingly, in the reference handbook, when they mention grounding, they actually don't discuss grounding configurations. It's all about ground resistance testing and this and that. Okay. But does it mean that they cannot test you on it? I would like to believe that if somebody pretends to know a little bit about grounding, at the very least, they should be able to explain all the advantages, disadvantages, issues, reasons for the issues for each and every one of the grounding configurations, whether it is ungrounded system, resistance grounded, high resistance, low resistance, reactance grounded, solidly grounded, and so on. Okay, so that's what we're dealing with when we come across P power. Codes and standards is a big portion, a huge portion, 10 to 15. So if we just round this up to 16, then you can see that about 20% of the entire exam is contained here, which is good news for folks who work with NEC day in, day out, who have exposure to NFP 70E and hazardous area classification. But if you're starting from ground zero, square one, if you're a recent graduate, if you're an internationally trained engineer who has no experience exposure to codes and standards, you really have to put in time and effort learning them. And within my program, I have an 8-part lecture series where I basically handhold the students through every step of the way just for NEC, then a multi-part lecture series for NESC, multi-part lecture series for NFPA 70E, and so on. Okay, so that was general power engineering, a little bit disjointed, a little bit random. Then we come across section number 2, which is circuits. Subsection A is analysis. And in my opinion, just like I mentioned, remember in FE electrical that amongst the big 5, math, circuits, electronics, power, and digital systems, circuits is by far the most important section because it has an outsized influence and impact on all the remaining sections, most of the remaining sections within the big 5, okay, with the exception of digital systems. Within circuits, over here in P power, section number 2, which is actually light in terms of comparison weightage, look at this, 21 to 32 versus 14 to 21. We have 3 line items, 3-phase circuits, symmetrical components, and per unit systems. They will make it or break it for you as far as P power is concerned. If you don't have a good handle on three-phase circuits, symmetrical components, and per unit systems, your life is going to be super difficult in section 3 and section number 4, and obviously in section number 2 as well. So that's why it is extremely important to go through the ins and outs of three-phase circuits, symmetrical components, per unit system, and have a very, very clear understanding. All right. Some of the remaining sections we actually build on top of FE electrical. So phasor diagrams we encounter in FE electrical to an extent, single phase circuits, FE electrical DC circuits, FE electrical, single line diagrams. If you're working in power systems and you have exposure to it already, ANSI device numbers and whatnot are given in the reference handbook for PE power, so it's not a big deal. And then section number B over here, subsection B, is again a little bit open-ended. And this entire line item that you see, relays, switches, and ladder logic, is missing, not given in the reference handbook. Variable speed drives, they just have one paragraph on it. They mention scalar versus vector. And battery characteristics and ratings, they have some decent details, but then again, a little bit open-ended. All right. The weightage is a little bit low. We spent a lot of time in the course working through this content step by step. I have multiple supplementary lectures on variable speed drives, PWM control, and a lot of additional details. Okay. Then we have section number 3. This is probably the most black and white section in the entire PE power exam specification, in the sense that the reference handbook does a really good job at giving you tons of equations and details, okay, for the most part. Now, the issue is that it gives a false sense of confidence to some students, thinking that I have over 2 dozen equations to work with. Worst case scenario, if I am in doubt, I can look at the reference handbook, plug and check my way through it, and I'll be done. Wrong. Because those equations at the P power level will make sense, or you will be able to use them if you understand the underlying concepts deeply. What I tell my students when they encounter section number 3 is that we have to work with 3 pillars. Okay, my drawing is really bad, but let us imagine that these are pillars, like the Colosseum, Rome, the pillars in Rome. Okay, equations is actually just one part of the puzzle. Those are given in the reference handbook. What is the second part of the puzzle? The circuits. Are you able to explain the difference between induction machine and synchronous machine by looking at the equivalent circuit? What are the key parameters? Where do they reside? Where are they hidden? Okay. And then the last pillar is phasors, phasor diagrams for induction machine, synchronous machine, transformers, auto transformers, okay, and graphs. So if you are hoping that just the equations that are given in the reference handbook are going to come to your rescue and you don't need to invest time and effort understanding the circuits inside out, and no need to worry about the phasor diagrams and the graphs, chances of you scoring above average in this section will be minimal. Okay, within transformers as well, we have equivalent circuits. There's so many concepts such as the relationship between voltage regulation, voltage drop, and power factor, which cannot be explained without having that deep understanding. All right, so that's section number 3 for you. Section number 4 is probably the most convoluted, most abstract section. We have some really challenging concepts hidden in here: power system stability, power flow, transmission line models, short, medium, and long, and fault analysis. Okay, SLG, DLG, LL, LLL, LLLG. Okay, single line to ground fault, double line to ground fault, line to line fault, line to line to line fault, and line to line to line to ground fault. Okay, how would you classify these faults? Symmetrical, unsymmetrical. What is the difference between a symmetrical fault and an unsymmetrical fault? How are you going to link the sequence diagrams with each and every one of these faults? Okay, the block diagrams, and how do you go about figuring out the sequence currents and then the phase currents. I go through entire derivation in my program for each and every one of them. Transformer connections, delta Y, your effective turns ratio, real turns ratio, transmission line models, short, medium, and long, power flow diagrams, reactive power flow, real power flow, the impact of magnitude, and the impact of phase angle, power system stability, critical clearing angle, the equal area criterion, the swing curve, the swing equation. All of these are very abstract concepts. And unfortunately, unless you have been preparing yourself with deep understanding leading up to section number 4, or working through section 1, section 2, and section 3, then only you can make sense of these topics. That can be a curse or a gift. It is a gift for those who have been investing time and effort strategically and using first principle approach up to the point when they reach section number 4. But if your understanding is wishy-washy, using ineffective exam prep resources, or being all over the place and hoping for plug and chug numerical questions, then it will become extremely difficult for you to manage these abstract concepts. And that's a fact. And guess what? The entire protection, this is what I was telling you earlier, 11 to 17 questions are contained in here. If you open the reference handbook, so 17 is 16. Let's round it down to 16 now. 20% on the high end, 20% of the exam, because the exam is 80 questions, right? So 17 divided by 80 is actually greater than 20%. More than 20% of the exam potentially can be in here. And guess what? The reference handbook does not contain any details. Right? So this is a high-level overview of what awaits you in the PE Power, regardless of what stage you are in, whether you're preparing for the FE exam right now, FE Electrical, or you are in the process of preparing for the PE Power exam. Keep this at the back of your mind. I hope you found this discussion helpful. If you're looking for a streamlined PE Power exam preparation program, I would recommend you to check out my website, studyforfe.com.